In this lesson, we're going to look at graphing with Excel. In this one, first part, we're going to look at how we plot a scatter graph, how we use regression trend lines in Excel, and we're going to use the trend function with Excel. We're going to do this by looking at an example. The table below shows the cost and length of different tram journeys across a city. And here's the table. We have one set of lengths of journeys in miles on the left, and their associated costs in pounds of journeys on the right. We're going to plot a suitable graph, and then use that graph to determine the relationship between the length of journey and the cost. Okay, so we have a set of data, like so. The table shows the cost and length of the journey, different tram journeys across the city, and the costs associated. And I've just taken that data from the question. Now, first thing it asks you to do here is to plot a scatter graph below showing the data displayed in the table above. And if you go up to the Insert tab at the very top here, third one along, you'll see that 1, 2, 3, the fourth little group in here is charts. Now you can hit the little down arrow here in the corner and it'll give you all charts. And you'll see that X and Y scatter is definitely one of them there, and we get all the options in there. But what can be nicer than to see a live preview? Now, you'll not get any chart unless that you highlight the table that you want to make the chart from to start off with. So I'm going to highlight the table first, and rather than go to recommended charts or go to the all charts, you'd see that the middle bottom one here says insert XY or bubble chart. And if I mouse over that, it'll give me options for bubble charts or otherwise. The one that we want is just a plain scatter graph. Just in the one in the top left, just with the dots in it. If you get any of the other ones with lines, they'll just try and join those lines together and make sense of it. And, well, that's not exactly what we want. So we just want a scatter graph, and we can drag this into place or otherwise. Now, as it is, this graph isn't totally useful because we really don't have any labels on it. We ultimately want to just use this graph instead of the table and present this graph instead of the table. So we need to label up this graph to make that work. And while we're still in the chart tools and design, you'll see that the first little bit here is add chart element. And if I click on that, you can see that I get some different options. The second one down is axis titles, primary, horizontal, and primary vertical. And if I click on the horizontal one, I can change the axis title here. Now you'll see that our values go from 0 to 7, and we're looking to see which of these maybe is the X value and which one's the Y. Well, you can even just look at the values and go, well, that one goes from 1 to 6.4, or that one goes to 1 to 3.4, and you should be able to see that the horizontal axis is the length of the journey one. So I'm going to type that in to here. So length of journey in miles will go in there. Similarly, if I go to add chart element and go to vertical, I can change that one to be cost of journey. And that one is in pounds. Oops. In pounds. The last thing we need to do is to add a title. Now there is a title on here at the moment that says cost of journey, and Excel has a tendency just to take one of the headers of your chart and make it the title, but it's not a great title. We want to replace that with something like scatter graph showing or comparing length of journey and cost. And you see that it's a bit big. You can keep it big if you want. I tend to just want it on one line, so I'm going to make it slightly smaller. And that is the first part of our thing done. So it says plot a scatter graph showing the data displayed in the table above, and we've done just that. Now, I don't really need the table much more at this stage. I'm going to clear this up on the right. And then the next part says describe the correlation between the length of tram journey and the cost, making reference to strength. Now, I'm going to do this just in words by observation of my graph first of all. So I'm going to make it a bit bigger. And then I'm going to look at it and say, right, well, what kind of shape can I see from the graph? And if you remember what we did about scatter graphs, we want to look at the direction that the points are really showing. And you should see that these points make an approximate line up to the right. And we call that, this graph shows a positive correlation, and if I could spell positive, it would be not much better. So positive correlation, that is to say that as one thing gets bigger, the other one gets bigger, or in this case, as the length of journey increases, so does the cost. Now you can see that not all values adhere to that little principle, but a lot of them do. They generally all follow this pattern, that the longer the journey, the more costly the journey is. Okay, we want to talk a bit about strength, and strength is really to do with, well, how well defined is that line, and we will calculate this both with an Excel in a second, but also manually in the class next week as well. So how to do all these calculations manually. So can you see a well-defined line there? Now I would suggest that you can here. And if that is the case, if you see a strong line, then you call it a strong correlation. If you could say maybe so I can make it, there's a general direction of it, but maybe not. Maybe I wouldn't find it easy to draw a line of best fit if you regard it as far as doing it manually on a scatter graph. Then you say mild, and then if there's very weak correlation, then you say correlation. But I'd say I can see evidence of a strong correlation between the two, or there's a strong link between the length of the journey and the cost of the journey. Okay, so that's part 3 done. We've made some sort of observation, and then it says insert a trend line to your graph including the equation and correlation value. Now I'm going to put away my format shape here on the right, and I'm going to look to see how I can get a trend line. Now Excel is very clever with these things. We are going to do this by hand in short time, but we're going to let Excel guide us through it. Now if I right click anywhere on the graph, I get a menu. Right clicking always gives you more options in Microsoft products or Windows. Left click does an action, and you'll see my little menu to the right has delete, insert, the match style, change chart type, select data, format grid lines, format axis. Not what we are looking for. However, if I right click on one of the points, you will see that we get an extra option, and that is add trend line, and I'm going to click it, and you should see a little menu open up to the right with trend line options. Now each of these menus has 3 little types: effects, fill in line, etc. We'll come back to those in short way. Now it gives you options for a trend line. We can pick exponential, we can pick linear, logarithmic, etc. Now the one that we want is a linear, and nearly in all cases it will be a case that we want a linear case, and so we're just going to leave it like so. Now if I look at some of the other bits that are there, we can change the name of the trend line or otherwise. We can also change the forecast. So if I look at my graph and go, I would like it to go a bit more to the right, then I can change this number to say 2 points to the right, and it'll do 2 points to the right. I'm not feeling inclined to do that, but I might want to see where it crosses the line at the left to give us an intercept. So I'm going to move it back 2, and it will certainly move it back. And I've also got to say I'm not a big fan of this dotted line. So I'm going to go back to my options here, and effects is 1 to the left, fill in lines 2 to the left. I'm going to change the colour to be black, and I'm not really fussed about that dashed line, so I'm going to change it to be a strong line. You could even say that it's maybe a bit too thick, so I'm going to remove the line down. And I have got a trend line, or what we will come to know as a regression line. So we did this by hand, where you would kind of use your ruler and move it about so you've kind of the same number of points above and below the line. You see in this case that doesn't actually work, but the distance between the points above is the same as the distance below. We'll do this by hand. It can be tricky to do by hand. We'll do the calculation of how you work out this equation type, because if we flick back to the trend line options, we'll see, say set intercept as an option. If I want to set it so that it goes through the origin, for instance, I can do that. Not the case here, but I want to display an equation on a chart and display what's known as the R-squared value on a chart. Now the equation matches the form y equals mx plus c, where this value of x is the gradient and c is where this crosses, or exactly the point where it crosses the intercept. And 0.1071 you can see is probably makes some sense as far as that little graph goes. But that is our equation on our plotted. And we also have an R-squared value. And an R-squared value is about the strength of correlation and about how close that it is to being a perfect straight line. This R-squared value, if R-squared is equal to 0, that means there's no association between or correlation between the two variables at all. If that R-squared value is between 0 and 0.25, say that the correlation is a bit weak. I mean, there might be some suggestion that it's there, but not enough to really worry about. If it's between 0.25 and 0.75, in between there and anywhere, it's still considered a mild or intermediate correlation. And if it's between 0.75 and 1, like our example here is, then it's considered a strong correlation. If the R-squared value was equal to 1, then we would have perfect correlation, and that would mean that every single point is exactly on the line. Now those values all range between 0 and 1. 0 means that I can't make any correlation between any of the values, and 1 being that all of the points lie exactly on the line. And you'll see that our squared value in this case is 0.9328. And 0.9328 indicates that there is quite a strong correlation between it. I'll show you in the next slide how you would maybe make a better case between them, but 0.9328 would indicate that our observation on the point above was solid. And that is our trend line on our graph with our equation and our correlation value. What's next? We're going to use the trend function to predict costs for associated lengths. So we have a scatter graph here. We're going to use it, or we're going to use the equation of it to determine values for lengths that we generally don't know, or to make predictions on that. Now, this is the one case where we might want to go back to our original table. So for convenience sake, I'm going to copy and paste this down beside what we've got. Like this out. So I'm going to copy my table down here, and we're going to use what's known as the trend function. I'm going to put this in capital letters. So the trend function predicts costs for associated journey lengths. And if you use any function in Excel, it always tells you how to use it. Now, if I start to type equal trend, I can double click on trend or I can hit tab, but it will tell me how to use it, and it says in brackets after it my known y's, and that basically says, right, put in the y values that you know so far. And if I look back at my graph, the y value was the cost of the journey, another good reason to label it. So I'm going to select all my y values there. It says once you put in your known y's, put in a comma, and then put in your known x's. So I'm going to select all my length of journey in miles and put those in. And then I want to put in my new x value, or really it's my test value that I want. And in this case, I want to find out how much a journey of 1 mile would cost in theory. So I'm going to just put in the number 1, put in a comma, and then it'll tell me, right, what do you want to do? What about your constant? The constant b is equal to 1, and the m values are adjusted so y equals mx. Well, that's not the case here, because our b, what they're saying their b value is set the intercept to 1 in this case, and we know that is not true. So I'm going to say make this true. So b is calculated normally. You can either type in true or double click here so that it says true and close our bracket. And we get that that is 65p. Now I have formatted each of these cells as it is so that they are currency with 2 decimal places. You can change that if you don't get that or otherwise, because we want to really predict the value that there is here. So it is 2 decimal places. If it took that off and put general, you would have something like that, but I want to make it a currency, so we'll go format cells and go to currency, 2 decimal places in the pound, and put it in. And if I look at my graph and go to 1, you can see that 0.65, that looks not bad. That looks okay. We do the same for the other functions, so our known y values, our known our known y values, comma, our known x values. And to show that it works, I'm going to click on the cell beside it so that it reads the value yet rather than type it in. You can do either. And again, change it to true. And close bracket. And it'll see that an 8 mile journey is £4.46. Okay, that looks like it could be true. I could have even went back to this point here, added my trend line and set this forward 2 spots. And see whether that 8 mile, £4, whatever, would have made sense. And sure enough, I think it does, but I'm going to take it back off. And then do the same for 20. Now if I drag down, it'll nearly do it for me. If I'd have set it up better, I'm just going to type it out again. So equals trend, known Y values, known X values, my value that I'm trying to test, my 20, and then true. And it'll tell me that a 20-mile journey is about £10.98. And that is that first example done. How to plot a scalar graph, how to put a trend line, the equation and the correlation value, and then describe it in words and use the trend function as it goes. You have an example 2 there that shows the number of people who visited a museum over a 10-day period last summer, together with daily sunshine totals. And we're going to see if we can plot a scatter graph and do the same calculations to see whether there's a correlation between the number of visitors and the hours of sunshine. So you can give that one a go, and if you have any problems, let me know.